I wanted to talk a little bit about x and y intercepts. Now you know how to find x-intercepts from a graph. It's those places where the curve crosses the x-axis. And you know how to find the y-intercepts of a graph, those places where the curve crosses the y-axis. I wanted to also look at how all of those points on the x-axis have something in common, and all of those points on the y-axis have something in common, and maybe look at how that relates to the equations. So first, let's look at the points lying on the x-axis. If you take all of these points and you look at their coordinate pairs right up next to each other, -5, 0, -3, 0, positive 2, 0, positive 6, 0, they all have something in common, that their y value is 0. Now, you can have, if you have a line, your line may cross the x-axis in exactly one place. And it's going to keep on going up here, and it's never going to touch it again. And you've learned that if you have a parabola, it could cross it in 2 places, or 1 place, or 0 places. It's possible to cross in 2. If you have more complicated functions, it might do silly things like cross in a lot of places, right? Or bounce off, not even cross. So any place that a graph touches the x-axis is an x-intercept. So if you look at all these x-intercepts, they have a y value of 0. If you go look at any equation that you're graphing, whether it's a line, or it's some kind of quadratic, or even if it's like an x to the 5th graph, like this might be, you'll find that if you know that the x-intercept has to have a y value of 0, that means it has to have a height of 0. All of these points lie on the x-axis. Here's a height of 0, here's a height of 1. None of these points are up here at 1, they're all down here at 0. If you let their y values be 0 in the equation, just like they are on the graph, then you can solve for the x value of each intercept. So it works on lines, it works on parabolas, and it works on everything higher and more complicated than that.